Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have an easy today again. It's called minimum operations to make array values equal to k. Right, so something similar to yesterday, like we have to do some operations, but our final outcome is a bit different. So let's see what it wants. So again, we have nums. This time we also have k, which is probably like what we want to reach, but we're not sure how to reach that yet. So again, the bounds are very small, like because it is an easy question. Yeah, but let's see what the question wants. So yeah, you're given that integer h is called valid. If all values in the array that are strictly greater than h are identical. Okay, right. So so basically like you can have one value that is greater than h. So like for example here, it is valid for 9 because like the only number that's greater is 10 and they are all equal. So that means it is valid. So you're allowed to perform the following operation. You can select an integer h that is valid for the current values. For each index I. Wait, where nums? Right, so you can like set all the numbers greater than h to be h. Is that what it means? So we want to return the minimum number of operations to make every element in nums equal to k. Right, it's still a tiny bit confusing, but let's see what we have. Right, wait, does that mean that like if a number is smaller than k, it wouldn't work at all? Yeah, because like if we look at example 2, like we have a 1 here, but like k is equal to 2, right? So we want all the numbers to equal to 2, but like obviously here we can only decrease a number. Yeah, and yeah, I'm pretty sure like you can just use greedy and it'll work. So you want to find the I think you want to find the largest number, and then yeah, so you want to find the largest number, and then you want to find the second largest number, and then you just want to like reduce everything like into that number. So you have like, yeah, so that's why like you turn all of these into 4, and then like the second number, like you can turn all of them into into 2, and then it'll work. Is that true? Let's look at this question. Yeah, honestly, like that will also work. And like if all your numbers are equal, so you can like reduce it however you want. But are there like any edge cases though? I don't know, because like is the highest h you can go. Yeah, so that means like every time you're reducing the number as much as possible. So it should be like by exchange lemma, it should be the the best solution, like the optimal solution. So yeah, I think we can just code it out now. So yeah, also like do we just want to like I think we want to combine the numbers first actually, because it doesn't really matter. Like if every time we are reducing to like if every time we are reducing to like the or the largest number to the second largest number, then like it just means that we have a bunch of like second largest number, and then like we'll look at the third largest, right? So we don't actually care about like the repetition. Like we just want to reduce like based on what the second largest number is. So yeah, I think like for sure we can just code this out. So what we want is so we want our nums. We want to set our local nums to like to a sorted list, I think. So sorted list, but we want to get rid of the duplicates. So that's why like we turn it into a set and then turn it back into a list. And then so first of all we want to check whether the smallest number is k or greater, because like that will affect the answer obviously. So if num0, we're guaranteed to have some elements, right? Yeah, okay, so num0 exists. So if it is smaller than k, it's not possible. And then now, so every time we just want to get rid of the, like basically getting rid of all the largest number, because like it will be equal to the second largest, right? So I think we just want to return. We also want to see whether like the smallest number, I guess like we have number of operations here. Yeah, so like the other edge case we have is like if the smallest number is 2, we don't need another operation to reduce the number like to whatever k is, right? Like if the smallest number is equal to k, but like for this case, like the smallest number is 3, so that means like after we turn all of these into 3, we have to do one more operation to turn all of them into 1. So like that's another edge case we have to deal with. So we can just do something like smallest is k, so that will be 1 if num0 is not equal, we'll just do like 0 maybe. Yeah, so we don't need another operation. We'll do this. So we don't need another operation if the smallest is equal to k, but otherwise we need another operation. So at the end we can just return smallest is not k. So if that's true, we need another operation. Plus, well, how many operations we are going to do? Like if we have like let's say we have like 3 unique elements, then we have to reduce it like once, so it will like become like a size of 2. So yeah, so that means like it will just be the length of the new nums minus 1. So that's the number of times we have to remove to actually get to like 1 element left. And then if that element is equal to k, we don't need to like do one more step. So that's why that's there. And I think that should be correct. Okay. Nice. So yeah. Yeah, I guess this question, like because the bounds are so small, you can also easily brute force this, I guess. But yeah, well actually this is like a pretty nice solution. Like well, this is n log n, but I actually don't think you can do better than this, because you have to like somehow find the largest number anyways. But yeah, thanks for watching, and I'll see you tomorrow. Bye.